Good evening. My name is Mohammed Abdulhamid Dawood. I'm a Senior Water Resources Advisor at the Environment Agency Abu Dhabi, and I'm a professor at National Water Research Center, but I'm now on leave from Egypt. I would like first to thank the organizer of the 9th International Conference on Water Resources and Arid Environment in Saudi Arabia. So my presentation today will be about the sustainable management and reuse of treated wastewater in the Arab region. Our region is an arid region, and we don't have a lot of water resources, and the renewable water resources per capita in our region is mostly very negligible, and in some countries it is less than the 1,000 cubic meter, which is the poverty line for water resources. The rainfall is mostly negligible except some in the south of Sudan and some minor frequencies in the northern coast of the Mediterranean Sea or the Red Sea. At present, most of the countries are lying below the poverty line, which is 1,100 cubic meters renewable water resources per capita per year, and except 2 or 3 countries, which is mainly Mauritania, Iraq, and Somalia, but the remaining countries are below, and especially in GCC countries, they are far below. They are less than even 100 cubic meter per capita per day, which is very making the situation is very stressed and under very stressed regarding the availability of renewable water resources in the region. This is also make a lot of it challenging to get the food enough to fill the gap between the existing food and also the importing food from outside the country. So most of the countries are importing food from outside the region, and in some countries the self-sufficient ratio for food is less than 15%. So means that 85% of the food is coming from outside the region. And to produce this food within our region, this means that we have a lot of pressure on the non-renewable resources which we do have and the resources which we have. At present, all over the world, they started to look after what we call it non-conventional water resources. Non-conventional water resources means the desalinated water or the treated wastewater. Our region actually produced about 2/3 out of the total desalination capacity all over the world. But the desalination is always very expensive, and it needs a lot of energy for production of this fresh water from the seawater or brackish water. Meanwhile, also it has a lot of environmental impact, like the brine water discharge to the Gulf, to the Red Sea. And it needs a lot of caution, and also it is very costly regarding according to the affordability, especially the low-income countries in the Arab region. So most of the region started to look after or to look for using the treated wastewater, which is a little bit cheap, it's available, and it increases with time. At present, the region is producing about something like about 8 billion cubic meter, or even recently, the statistics recently indicated we are producing about 12 billion cubic meter of treated wastewater. If with this treated wastewater have been treated carefully and the quality have been managed carefully, then this water resources can be used in different uses. Either the agriculture irrigation, the aquifer recharge, or district cooling, or irrigation of landscaping, amenity plantation, a forested area, and many other purposes could be utilize this treated wastewater. In the region, our region now, most of this water, the utilized quantities of this treated wastewater mostly is used for agriculture. Very minor quantities are used for groundwater recharge, but most of this here, as have been indicated here with this gray color, it is discharged to the water courses or to the environment itself. So this is have a lot of environmental impacts, and also it means that we are draining money and draining resources which is not utilized or efficiently utilized or efficiently used. So we have to look forward using these resources as part from the water balance for each country within the region. As I mentioned, at present we are producing about 12 billion cubic meter. About 6 billion are treated, 6 billion are not treated, but only 4.7 are reused. And the remaining, which is about 8 billion cubic meter, are discharged back to the environment with many environmental impacts and challenges. Our expectation, or by the modeling this volumes and the prediction of this volumes, this means that by 2030, the total treated wastewater production will be reaching about 30 billion cubic meter a year. This is a huge amount of water, and if we are not ready to utilize this water, this means that it will be discharged back to the environment or to the water courses. There is, of course, a lot of challenging regarding the reuse of treated wastewater, especially the insufficient investment. It is the lack of financial resources. It is one is very important issue. The cost recovery and the policy coherence. We have also the limited institutional capacity to use this treated wastewater and the policy framework. There is no policy frameworks in most of the country regarding reusing treated wastewater. Also, we are not managing the wastewater and stormwater and from the floods, and the industrial effluent is also sometimes added to the domestic water collection, which add a lot of additional wastes or additional pollution, which is not normally treated even by normal treatment plants. I will give here a very good example from Abu Dhabi Emirate as a case study, which could be followed by other countries or by other states in the region. In Abu Dhabi Emirate, we have three main resources. The first one is the groundwater, which contributes by about 60%, and we have the desalinated water, and we are producing about 1.8 billion cubic meter in UAE in general and Abu Dhabi. And we are using also the treated wastewater. But at present, this is used either for agriculture, domestic, a forested area, amenity plantation, and other purpose. In Abu Dhabi Emirate, we have more than 32 treatment plants. Out of them, we have only 2 are big, but the remaining are small scale treatment plants. But this, we are producing about something like 400 million cubic meter of treated wastewater. Out of them, only 40% is reused, 45% is reused, and the remaining, which is 55%, are discharged back, and mainly to South Al Musaffa area in the Arabian Gulf. So it is polluted this area and making a lot of environmental challenges for our marine ecosystem. Especially this area is mostly closed system, and the water is not circulated. The ambient marine water is not circulated in a proper way, so it makes a lot of environmental challenges for us. Our expectation that this will be continuously increased by 10%, from 8 to 10%, so it could reach about more than 1 billion cubic meter by 2030. So we started to put a plan to utilize this water. This is the schematic diagram about the production, the collection, and then the treatment, and then the disposal to the environment. And if it's not disposed, some of them are at present utilized. The present utilization in Abu Dhabi Emirate is either for using it for agriculture, for some crops, especially fodder crops, and some also some olive trees, peaches, and some oranges. But most of this water are not used for agriculture. This is I'm speaking here about the 45%. So most of it are used for landscaping, for amenity plantation, for root verges, and not directly for continuous use in agriculture. But there is a plan now to utilize this. Also, we have a very good experiment to advancedly treat this water and reuse it for agriculture in 230 farms. So we are planning now to increase the reuse of treated wastewater in agriculture. So we started to plan for 2 mega projects. We call the first one Dubai Road Project. In this, the length of, we will pump the water from here, from the end of Abu Dhabi Island, with a pipeline of with a length of about 45 kilometers. And this will carry about 140,000 cubic meter a day, and the water will be used for the irrigation of farms and forests. And we have here more than 2,100 farms, which be actually at present they are using desalinated water. So all these farms and this forest along this pipeline and this area is irrigated with desalinated water, which is the 1 cubic meter of desalinated water is costing the government something like 11 dirham, which is more than $2 a day. For each cubic meter. So by using this amount of water, I will save about 140,000 cubic meter of desalinated water, very big cost for the government. The estimate cost for the infrastructure of this pipeline is about 180 million dirham, Emirati dirham, and the construction will be completed by end of 2021. And we will be ready to irrigate 2,100 farms, in addition to some afforested area, landscaping, and amenity plantation along this pipeline. So, and we will save this huge amount of desalinated water daily from the consumption or from the farm use in this area. The second mega project is what we call the Al-Ain Road project, and the water will be pumped from Al-Waspa treatment plants along Al-Ain Road up to Al-Khatma and Al-Khazna, and it will supply about 2,400 farms, in addition to some afforested area, and the road verge of Al-Ain road verge along this line. The length of this line is 70 kilometers, and the daily capacity is 250,000 cubic meter a day, and the capital cost is 750 million. All of these farms, all of this afforested area, and here along this pipeline is irrigated with groundwater. And unfortunately, because the groundwater aquifer within this area is non-renewable aquifer system, so we are deteriorating the groundwater, and the groundwater is depleted. The table is falling down here every year by 6 and 7 meters sometimes every year. So we are facing a very big challenges if we continue using only the groundwater. With replacing the groundwater in this area with treated wastewater, this will enhance the situation of the aquifer system in this area, and it will relieve the pressure from continuously using the deteriorated groundwater. And most of these farms, which is more sometimes, as I mentioned, 2,400 farms, most of them are non-operated at present because of the deterioration of the groundwater, and the high saline water exists in this area. So by pumping this 250,000 cubic meter of treated wastewater, I am actually replenishing the aquifer, and I am reserving the investment in these farms in this area, and also I am helping to recover and to enhance the situation in the future. Also, the volumes between the peak in the summer and winter demand for these farms will be utilized to recharge the aquifer system and to enhance the situation that could be utilized during any emergency. If there is any failure in the pipeline or any problem in the pipeline, the farmers can utilize the groundwater, which is enhanced and recharged by treated wastewater in the future. Within this area, we will save something like about 4,000 groundwater wells, and it will save a huge amount of operational cost for the owner of these farms. When we speak about this, we have a lot of workshop and sessions and the brainstorm session with the owner of the farm, how they can use the treated wastewater, which irrigation methods they should use, what is the criteria which they should take into consideration, what will be if they would like to use available alternative resources for potable supply and the livestock potable water supply. So we started to have another potable water supply from the network, from the desalination network, and also we will keep one groundwater wells as a backup for any emergency, and we will also advise them how they can carefully select the irrigation technology and the irrigation method to take into consideration any health risk or to protect the soil and the groundwater from the salinity and toxicity hazards. Is agriculture is only used in Abu Dhabi Emirate? And the answer, of course, is no. Agriculture is one of the main demand centers that they can utilize the ground, the treated wastewater. But we have another alternatives like the urban use for, as I mentioned, for landscaping, the recreational use. We have many now fountains and artificial lakes, which they use the treated wastewater, and also we have to use it for environmental enhancement. For the groundwater, we are planning to use for the groundwater also, and for industrial use like district cooling, industrial use for outdoor use for landscaping or greening, but not actually in the industrial process itself. And also for potable water use, if we add membrane technology, if we use membrane technology. But our visibility study indicated that adding membrane technology will add additional cost, and also we will have some brine water discharge back to the environment as a rejected water or brine water produced by the membrane technology. And we will need also additional energy, so it will be costly. So it is better to use the tertiary treated wastewater directly for irrigation, for district cooling, for aquifer recharge, or whatever. Before we starting this project, actually, this was a proposal to the recharge the whole quantities of water directly to the aquifer recharge. But our detailed visibility and technical study indicating that it will not also technically viable and economically, and it's better to use it directly for irrigation. And if we have additional excess water which is not utilized for irrigation, it could be used for recharging the aquifer. But recharging the whole quantities into the aquifer, it is not the right solution technically and economically. Why? Because the aquifer system here, as you see here, for in the coastline, it is mostly of water is brackish water, and the volume produced near the Abu Dhabi Island or Al Ain, it's actually lie above the aquifer, which is mostly brackish or saline water. So adding additional treated wastewater to this will not enhance the situation. So it's better to use it directly. And if we need to recharge the aquifer outside this region, it will be very costly to build the infrastructure and pumping station to the aquifer, which is suitable for recharge. So we started to build the infrastructure to utilize it directly for irrigation. And if we have excess, we will enhance locally the areas under this farm by recharging the aquifer system within this farm. So visibility wise, we find that it will be better to use it directly for irrigation and not for aquifer recharge. However, if you have excess water, you can use it for enhancing the groundwater aquifers locally. And if you would like to recharge, you need a lot of infrastructure. So you have to build the pumping stations, the main transmission pipelines, and then the recharge system, and then the abstraction or the recovery system, the monitoring system. All this will be very costly, and you need also a very comprehensive monitoring to evaluate the recharged water in 3-dimensional, horizontally and vertically, and also the quality of it and how it will interact with the native groundwater within the aquifer system. So these items will add a hell of cost for the end users. Actually, the advantage of using the treated wastewater is a lot. Like exactly you are relying, it is a reliable source of supply, and it is continuously increased with the increasing of the population and increasing of the demand for potable water supply and domestic water supply. It is available near agriculture application because it's produced from the urban areas. It is highly content of nutrients, of course. It is because it is containing huge nutrients like nitrate and phosphorus, which is very good for to enhance the growth of the plantation. We are benefiting from the rural population if we collect the wastewater and treat it and reuse it. We have the experience within the region how we can deal with the treated wastewater, how we can transport it, and how we can utilize it, how we can use it. Actually, also we have the guidelines and the standards, and we carry in Abu Dhabi Emirate a very comprehensive study with FAO, jointly with FAO, to evaluate and to put a monitoring plan for the reuse of treated wastewater in agriculture in Abu Dhabi. Of course, always there will be some necessary consideration and concerns which should be tackled very carefully before going for the use of treated water. The most one is the risk of human health, especially the farmer or the end user that they are dealing with this quality of water or this type of water at a farm level. The risk on the environment, like if it contains heavy metals or it contains any pollutants which could affect the groundwater or the soil within this area. One of the very important issue in our region is the social acceptance. Social acceptance, we started to solve it in Abu Dhabi by making a lot of brainstorming, a lot of sessions, awareness campaign and sessions for the end users. And we find that there is a lot of acceptance because it's actually a comparison between a fresh water, which is tertiary treated wastewater, with a groundwater, deteriorated groundwater with a salinity of more than 10 to 15,000 ppm, which is it affects their investment and it has no revenue or no back from this site. So they started to accept it. The end users or the owner of the farm, they started to use it, especially after many sessions, awareness sessions and awareness campaigns, which we started since 5 years back, before even the implementation of this mega project. Also, the cooperation between different sectors. Sometimes there is some competition between different sectors. Should we use it farming? Should we use it for district cooling, for aquifer recharge, or for landscaping and amenity plantation? So there is some competition. And we should very carefully put the prioritization and who should we use it effectively and efficiently, and which sector is more beneficiary and economically viable more than others, and where will be the return. So we started to make this analysis and the feasibility study. Also, sometimes we need to have required for additional treatment if it's not, but unfortunately in Abu Dhabi, the 32 treatments plants are all of them tertiary treated, level up to tertiary treated. So the quality, according to FAO study and the FAO guidelines and standards, it is suitable for most of crops except some edible crops, which is it's not recommended to use it directly for reusing of treated wastewater. The public health consideration also should be taken into consideration. The design of the wastewater, either transportation, distribution, and also the irrigation system, which you will be used for at the end on the farm, it should be tackled very carefully and it should be designed very carefully. In conclusion, of course, the treated wastewater is considered sometimes, from my point of view, as a renewable resource, part of from our renewable resource, and we have to go ahead and discuss in details how we can utilize it and utilize it. And I gave you an example in Abu Dhabi that by the end of 2021, we will reach zero discharge to environment, and we will utilize 100% of our treated wastewater, and it will add to our water balance in Abu Dhabi Emirates. So it have a lot of environmental sustainability. It could be help to protect the groundwater. It could be help to as an alternative resource for desalinated water and irrigation. So it will help the environment, and it will help also economically to save a lot of money and a lot of energy which is used for desalination, and also help the environment regarding stopping discharge of this treated wastewater to the environment, either the water courses, the desert dunes or whatever. So it also have a lot of economic efficiency compared with other alternative resources. For instance, in Abu Dhabi Emirates, we have some water resources valuation, which indicated that the groundwater is costing us between 5 to 7 dirham, which is something like $1.5 per cubic meter, compared with $2 plus for desalinated water, and with less than $1 or about $1 for treated wastewater. So it has some economic efficiency, and it is economically viable to use it. It also can help to contribute to our food security. As I mentioned, most of the countries within our region has a lot of shortage in the water in the food supply, and the self-sufficiency ratio is very low compared with other regions. So this could help to contribute to the increasing the self-sufficient ratio and minimize the bill of importing food from other size countries. Exporting food from the neighboring countries or within the region. So it will help also the region to contribute to food security issue. With this, I would like to thank you again for listening, and I'm ready for any clarification or questions. Thank you very much, and I will have my details here. You can contact me at any time. Thank you very much.